My screen is visible. Nahin. Hello? I'm not
no.
able to see anyone.
Good morning, everyone. We are starting the session in another 1 or 2 minutes. Please stay tuned to this.
A very warm good morning to one and all present here today. I hope each one of you is safe and sound and is doing good. I welcome you all to our webinar session jointly organized by Indian Concrete Institute Pune and Ghaziabad Center along with Ultratech Cement Limited every Saturday 11 a.m. Our today's session is based on panel discussion on quality assurance, quality control systems in precast construction. The panelists for the discussion are Mr. Shailesh Dhire sir, who is co-founder member and precast head at Indo Global Precast System LLP. Mr. Rajendra Kulkarni sir, who is director of engineering at Precision Precast Solutions Private Limited. Mr. Dinesh K. Bhandari sir, who is chief engineer and director at Concrete Curations Private Limited. And Mr. Shashank Vaidya sir, who is director at Gem Ink Serve Private Limited. I would like to thank all our panel members for accepting our invitation and for taking out their precious time to deliver this lecture. It's an honor for all of us to have you all on this platform. Now, I would like to extend my greetings to distinguished dignitaries present with us today. We have Mr. Prasad Sevekari sir, who is Secretary for ICI Pune Center, Dr. Vineet Bajaj sir, who is Treasurer for ICI Ghaziabad Center. We also have with us Mr. Dhananjay Bhosle sir, who is Convener for SEMCON 2021. From Executive Committee members of ICI Pune and SEMCON organizing team, we have with us Mr. Mangesh Hardas sir, Mr. Amit Hardas sir, Ms. Sujita Kalwar ma'am, and Mr. Ramesh Kulkarni sir, and Ms. P. Usha Devi ma'am. We also have with us Engineer Vipin Chaudhary sir from Ultratech Cement Limited, who is Regional Head for Technical Services of UP1. Moving on, I feel delighted to welcome Dr. Vineet Bajaj sir for giving us a brief of ICI. Over to you, sir.
Good morning, ma'am. Can I have the sharing rights?
Yes, sir.
I hope my screen is visible now.
Yes, sir. It's
Presentation.
visible.
Yeah, a very good morning to one and all, and welcome to the 62nd webinar of ICI Ghaziabad, a total of 91st lecture being conducted today, and it's a privilege for me to be sharing the dais with the esteemed panelists. Today we have Shri Shailesh Dhire sir, Shri Rajendra Kulkarni sir, Dinesh Kumar sir, and Shashank Vaidya sir. And the topic for the day is the panel discussion on QA and QC systems in precast construction. And the moderator for the day is Shri Suresh Tripathi sir. A brief introduction about ICI. ICI was registered as a society on September 7, 1982. So we have already come into our 39th year. Headquarter of ICI is in Chennai. There are a cluster of 44 regional centers across spread across India. We had shown an impressive growth of having approximately 13,000 enrolled members, 351 organization members, 266 plus student chapters across India. ICI have various members profiles like practicing engineers, designers, architects, consultants, manufacturers, research scholars, academicians. And lately we've been pushing students to be part of this so that we can decrease the gap between academia and industry. ICI is managed by the governing council, which consists of president-elect, 4 vice presidents from all 4 zones, that is north, east, west, south, general secretary, 12 elected members, including 2 organization members, 2 past presidents, 4 co-opted members, and chairmen of all ICI centers forms the governing council of ICI. ICI centers are managed by executive committee. All the executive committees have chairman, vice chairman, secretary, treasurer, and committee members who are selected for a span of 2 to 3 years, depending upon various regions. The objective of ICI is to promote growth of concrete construction and its specializations, to disseminate information and train personnel for need of changing concept, to collaborate with national and international agencies, to identify R&D problems of practical relevance. In addition to this, we also have institute. We also are involved in institute and distributing awards for achievements in concrete construction technology, so as to promote in-depth research in concrete, to arrange national and international workshop, conference, seminars, and exhibitions, to provide us, so that we are providing a good platform for our young generation to understand the importance of concrete and the need of the hour, that is how we can work on various improving various types of concretes. To arrange annual lecture series on selected topics of relevance for concrete constructions. Here is a list of the webinars which ICI Ghaziabad has conducted in the past 18 months during the COVID time. So the foundation basically happened on 29th of May last year. We had a 3-day international webinar on durability design and construction aspects of bridges in association with CRRI, and there were 18 lectures delivered. Since then, we have been regularly organizing webinars on Saturdays, and as I've shown earlier, this is in continuation to that. We have speakers across various government bodies, international bodies. AK Jain sir, Jules Korean sir, Dr. SK Singh from CBRI, and we professors from NITs are few of the eminent speakers who have shared their experience in the past 18 months with not only students but concrete technologies across India. Last week, this is again the list continues. I'll skip this because of the time paucity. So last week we had a technical talk delivered by Engineer KP Abrahamji, former CPWD Chief Engineer. That was our 90th lecture. That is Tale of Two Temples, and this happens to be our 91st lecture. So today's again I'll be, for those who have joined late, today's topic is a panel discussion on Q and QC systems in precast construction. The panelists are Shailesh sir, Rajendra sir, Dinesh Kumar sir, and Shashank Vaidya sir, and the moderator for the day is Tripathi sir. In addition to the various webinars, 7th of September happens to be a birth date of concrete ICI, and therefore the September across India is celebrated as a concrete month, I'll say, because various technical events are happening across India. ICI Ghaziabad celebrated its concrete day on 11th of September. Sanjay Pansar from BIS, Bureau of Indian Standards, was the chief guest for the day. This is the photograph of the inauguration ceremony. Annual award function on the concrete day. These were the few recipients of the various awards. I'll be sharing the list of the awardees, the types of awards which are being distributed on concrete day. Few of the photographs. In addition to this, last year we made sure that we continue this celebration, and 12th September last year was the day that we decided that we'll have the webinar in virtual mode, because to ensure that we are following the proper COVID protocol. So we celebrated concrete day virtually. Concrete day celebration last year, that was 2019 on 7th September. That was the concrete day celebration, and few of the photographs. We have chairman of that time, and chief guest for the day was the KP Abraham sir. ICI Ghaziabad annual awards includes outstanding concrete technology, outstanding young concrete technology, outstanding concrete structure. These are the few recipients of outstanding concrete recipients. Sorry, I beg your pardon. The Governing Council meets once in 3 months. Photograph of the Governing Council having a meeting in New Delhi. AGM held in September every year, mostly in Mumbai or Bangalore or Chennai region. Annual award function of ICI, that is the 29th AGM, which was conducted in 2012. ICI international brand events include Asian Conference on SEC of in concrete, which happens once in a year, a platform in which experts from all across the world participate and share their experience and knowledge. A few of the photographs. Cultural program also are conducted so as to give the flavor of Indian culture. ICI Innovative World of Concrete, it is conducted once in five years, an event. It's an international event combined with exhibition and platform to discuss and disseminate the knowledge on concrete. ICI IWC 2013, which was conducted in Hyderabad. Few of the photographs of exhibitions. The event in collaboration with other professional bodies. This is ICA AFC seminar on green technologies for sustainable concrete construction. Was conducted in April 2012 in ICA, and the host was ICA New Delhi chapter. Conference organized by ICI Ghaziabad was the repair and rehabilitation of concrete structure at Ghaziabad. That was in May 2011. After that, we organized an international conference on trends and challenges concrete structure again in Ghaziabad in December 2013, wherein we had participants across various Europe and Middle East and US also. This was a photograph of the roundtable conference on white topping at Mumbai, New Delhi, Chennai, Hyderabad, which happened in the last decade or so. A certification program being conducted in collaboration with BMTPC, that is concrete testing for lab techniques and field supervision, in 2012. As I've already informed, Concrete is 7 September is celebrated as Concrete Day. It's an annual event for all the center to celebrate the formation of ICA. Photographs of Concrete Day celebration from various ICA centers, not only Ghaziabad but other centers also. Apart from that, ICA makes sure that we are providing proper concrete education and training, and these are the photographs which have been conducted, training exercises being conducted across India. ICA headquarters annual awards. This is a list of awards from best paper to best PhD thesis to lifetime achievement award. Anyone who has started working on the field of concrete can win an award, like by publishing a good paper or submitting a good PhD thesis. To the one like people who are currently sharing the dais, many of them are recipient of outstanding concrete structure award or lifetime achievement award and other awards. These are the few photographs of eminent personalities across India who have worked in the field of concrete in the past 30 years, winning the lifetime achievement award. Not only this, ICI understood that with the passing on time, they understood that collaboration with international bodies is the need of an hour, so that we can work cohesively with other concrete bodies. So ICI have entered into MOU with ACI, that in American Concrete Institute, Concrete Institute Australia, Korean Concrete Institute, RILAM, Singapore Concrete Institute. We are also member of Asian Concrete Federation, associate member of FIB for exchange of technological information on concrete. The various researchers who are related or interconnected with ICI had helped ICI to come up with the technical monographs. We have a monograph on formwork, high performance concrete, durability of concrete structure, and so on and so forth. So many other monographs are also available. ICI publishes its own journal that is quarterly based. So these are the photographs of ICI journals which was published last year. We share e-bulletin with all our members. Each member receives an e-bulletin each month with the various informations related to what has happened in the past 1 month in the field of civil concrete, not only in India but across the world. Technical committee of ICI was constituted to formulate unified codes, standards, guideline, handbooks, and the various members of ICI body, various ICI members are also part of technical BIS technical committees, and are working cohesively to improve the codes, standards, and handbooks and guidelines. Few of the ICI technical codes, that is fiber reinforced concrete, precast construction of building, concreted mixtures, and unified for concrete construction, recycling of aggregates, decorative concrete, alternative to river sand, concrete durability in concrete flooring. These are available on the website. Those who want to purchase, they can go for it. Handbook on it has been just released. This is a handbook on waterproofing of concrete structure. And in the past 1.5 years, there were regular webinars, not only by ICI Ghaziabad but other chapters also, who have been doing webinars on waterproofing, understanding the need of the hour. It's available for 1,500 rupees for postage charges, and discounts are available for members, or if you want to buy in bulk. All these details are available on the university on the ICA website, and those who want to become a member of ICA body, they can also visit the website. All these information are available on the website. New initiatives in the past 18 months, social media, since we understood the need of the hour that seminars are now being taken care over by webinars. So far, we have been active, ICA has been active on social media for effective interaction between ICA members. This is one of the prime example. E-learning portal for education and training. Job portal is there for students who are member. They can go and find out the new available jobs in the field of concrete and or sites. Benefits of becoming ICA Life member: concessional delegation for fee to participate in international national conference organized ICI, access to the concrete portal on the website, recipient of quarterly ICI journal, as well as I've told, e-bulletin is available, publication of technical article in ICI journals, publications of ICI concessional rate, access to ICI reference library, support from ICI to conduct training. As a professor in SRM University, I'll add on to that becoming, once we have become ICI member, our university have become member, they have conducted various they have helped us in organizing various industrial visits, and also this is one of the support which is being provided by ICN, and the webinars are free for my students to attend. Participation in ICI technical committees. Above all, ICI events provide a uniform platform to learn and share the best practices in making good concrete, where sellers and buyers meet together. Benefit of becoming ICI organization member: fee delegation, concessional delegation fee for institution members, recipient of 2 copies of quarterly ICI journals, recipient of monthly bulletin. Again, I've informed this. Student chapter, the objective is, the clear objective is to bridge the gap between knowledge and practice, that is academy and industry, to keep them informed of the happening in the field, to prepare them to face the challenge in their field, in the career. And not only this, ICA web events, wherever there are chapters, they make sure that students chapters are invited to participate in various events, and thereby helping them to directly interact with the academicians, industrialists, or industries or consultants working in the field of concrete. A few of the benefits of student chapter: support in calling professionals, support in conducting training programs, technical training programs or visits, access to the library, concessional delegation fees, participation in ICI conducted competitions, publications, and once you are a student member, then you get a concessional fee to become a permanent member ICI after graduation. To be a good student chapter, we have laid down few. It's not that ICI want the student chapter should be sleeping. So few of the requirement of continuing a student chapter: they should organize only 2 technical lectures by eminent personalities, organize technical report writing competition, undertake technical visit to construction site, organize any other technical activity like exposition of new building materials, elect office bearer for students, so that they should learn to manage the things. Report of all these activities had to be submitted to the chairman of the Secretary General, under which the student chapter is falling. So to make sure that students are paid for their hard work, in the best student chapter awards is declared every year. The student chapter is declared the best which have worked in the past 1 year. So there's a point system. If they are organizing guest lectures, 3 points per lecture. Webinars, for conferences and workshop, 5 points per program. For visits, 3 if it is a local, 5 for outstation. For competition. So this is how we judge which student chapter is the best student chapter, and they are being rewarded. And a photo gallery of student chapter across India. Site visit by student members. I have already taken so much of your time, so on this note, I just want to thank everyone, and welcome again to all to the 61st webinar of ICA Ghaziabad. That is the total 90th lecture. Sorry, this was the last on last year which has happened. I apologize by KP Abraham sir, and welcome to the today's webinar on panel discussion on Q and QC system in precast construction members. I again thank ICA Ghaziabad, ICA Pune to who has given this opportunity to introduce ICA. Thank you, and on to you, ma'am.
Thank you so much, sir, for giving us a brief. Now there is a small announcement for all the participants. I request you to please keep posting your questions in the chat box pertinent to the topic. We will be taking all your questions towards the end of the presentation. Moving on, I now welcome Mr. Suresh Tripathi, sir, who is a chartered engineer, fellow of Institution of Engineers India, life member of ICI Madras, for panel discussion moderation. Over to you, sir.
Yeah, good morning to everyone. Am I audible?
Yes.
Yes, sir.
Okay. The ball has been set in a very good way, and very happy to note about this ICI program. And Salesh, can you open this our presentation?
Yeah. Can somebody make me presenter? I can display his presentation.
Yeah. See, this event is basically a curtain raiser for SEMCON. SEMCON 2021 is being organized, especially in Pune. And one of the theme for this year is advancement of precast technology. And with a curtain raiser, we did, next slide, please. In this, we are focusing on precast technology because we know that most of the people who are there in this are understanding that precast technology provides improvised quality of construction using minimum resources like time, cost, material. And we all know that it is constantly providing efficient and improvised quality. But we find that still there a lot is to be done, and benefit of precast technology is not being utilized completely because of lack of information on methods and techniques available in Indian market. So to do this, we had done a container for this, and next slide, please. So in this, we had taken up the various topics in this platform, and 3 events have already been done, and today is the 4th event on QA and QC system. So next slide, please. So taking, if you just see into the quality management assurance, the quality management and assurance and quality control of precast members, there are 2 basic levels in which we have to understand the things. One is in-house quality assurance program with continuous in-house control. And second is the plant certification and the quality control supervised by the independent body. Here, to start the things, I would come to Shashank Vedya sir, in which he is having a great experience in the PMC side of the precast projects as well as the Cast Institute side. So one of the questions which I would like to ask from Mr. Shashank Vedya sir is, what is the fundamental difference which you find in the quality management systems of precast and Cast Institute, which is creating issues? And yeah, please, sir.
Can somebody make the is my screen visible? And
Yes.
Yes, sir. It is visible.
okay, so I would like to show a slide which lists the fundamental differences between the quality management in precast as well as cast in situ construction. And any effective quality management system must account for these differences, because these are the things that that influences the behavior of different stakeholders. And amongst all the factors, I think one of the most fundamentally different thing in precast is the presence or absence of client or client's representative. We all know that in cast in situ construction, client's representative, in fact, quite often a very large team of client's representative is always available at site, almost 24/7, and they continually see not only the quality of incoming materials and the process and the end product. This is completely missing in precast. So the client's presence is virtually when the client receives the product at his premises, at the site or wherever the erection is going to take place. So the fundamental difference, therefore, too, is the precaster has far greater responsibility, though he has a freedom that there is nobody looking over his shoulder every hour or every day, but he has great responsibility to deliver the product which meets requirements. Second, because of this, there is greater emphasis on product quality as compared to an equal emphasis on process and product quality in cast in situ. I'm not saying that process quality is not important. I'm saying the client does not interfere or does not supervise it on a micro level. So therefore, on one hand, the precaster has the freedom, but he has a great responsibility to ensure that the process is correctly followed. The second fundamental difference is, and all of us, those who have been working in the cast in situ construction industry, is rejecting a non-compliant concrete part is extremely difficult. It has got very serious repercussions. You need to do diagnostics. You need to come out at the solution. It consumes a lot of time, energy, cost, and morale of people. And therefore, in cast in situ construction, everybody is very averse to rejecting something. And this dictates it motivates people to behave in a particular fashion. I always believe that if rejections are easy, then rejection can become a tool to quickly upgrade the quality of the structure, which is what cast in situ struggles from. In precast, because elements are independent of each other relatively until they are installed in the structure, it is much easier to reject one particular unit or even a lot of concrete, a particular lot of precast concrete. And that, I think, should put great emphasis on doing it right first time on part of the precaster. Other fundamental differences are precast employs and deploys a lot of equipment as compared to cast in situ, where still use of manpower is far more prevalent. So it is easier to raise the bar in precast concrete construction as compared to the cast in situ. One more fundamental difference is in cast in situ construction, the structure doesn't move. It is at one place. It is stationary, and traceability of a particular element is of no great requirement. So a column is a cast, or a footing is cast, or a beam is cast. It stays there, and you have its traceability till the structure is handed over. In precast, after the element is taken out from a mold, it undergoes multiple handling, couple of handlings in the factory itself, then in transportation, stacking at site, and then in erection. And in order to trace back any problem, it is extremely important that each individual unit is traceable, and this has to be embedded in the quality management system. Otherwise, there will be a big mess if something goes wrong at site. And lastly, one major difference is because precast fundamentally we are producing large number of similar units. Statistical quality control can have significant influence, significant role to play in precast as compared to cast in situ. And cast in situ, the only place we are using principles of SQC is the acceptance criteria of concrete and some amount of material testing, but that needs to be very widely used in precast technology. So these are the fundamental differences between the quality management system of precast and cast in situ that need to be factored in while developing a QMS for precast. Over to you, Mr.
Very well said, sir. next question which I would like also to you to answer on this is how you find the difference in managing the concrete production and its quality QC different in precast set and this one, what do you call in cast in situ scenario?
Here I would like to focus on what are the advantages we can leverage in precast concrete construction.
Absolutely, I would like to.
Yeah, one of the biggest advantage that precast is factory-based production. It is geographically at one place, so all the incoming materials you can afford to buy or procure all incoming materials: cement, cementitious material, coarse aggregate, fine aggregate, admixture, almost everything from a single source or at best two sources. So this removes one of the largest contributor to variation in concrete properties. If you are able to achieve, if you have to source material from the same source, this is one of the biggest advantage. Second, very big advantage is that the source where the concrete is produced, the batching plant, and the end place where the concrete goes into the mold, their physical proximity, in time and space is so close that concrete after production can be virtually put in the molds in 15 to 30 minutes max. As against this, in cast in situ construction, there is a time lag of sometimes more than few hours. 2, 3, 4 hours are not unusual in urban places. So this coupled with the good quality of molds that we can afford in precast and the form vibrator that is the norm in precast, the degree of compaction in precast can be far superior to that ever you can achieve in cast in situ, given everything remaining the same. This places far greater freedom to the precaster to choose appropriate work area. My experience is there is a lot of problem we face in cast in situ construction because we tend to solve all our problems by choosing extremely high workability of concrete. We don't have that constraint in precast. The third difference is, of course, the controlled environment in a factory where you are not affected by rain, wind, or dust for much of the period. You can guard against these things that can create problem for concrete. One more difference, which is more commercial in nature, in cast in situ, whenever you are using RMC, there is a difference between the buyer and the user. Buyer and seller, there is a difference. Here in precast, the producer of concrete and the user of concrete, that is the factory, is in the same entity. So there are a lot of no commercial disputes possible in this situation in precast, which is, you can focus on technical issues rather than commercial issues. And
I do agree with you this commercial things, because in one of my projects which I was giving one of the hollow cores to a project, so what had happened that hollow core was put on the cast in situ walls, and cast in situ wall concrete was being outsourced from a RNC plant. And when at one point this the work got delayed because the wall was not the concrete which was put in the wall was not up to the standard. So the project got delayed for more than a month. We were not able to put the hollow cores on that.
Right.
So this is one of the very aptly said, sir. Quality control in cast in situ, and this one is.
At the same time, there are certain challenges. Can I complete? Then, yeah.
Yes, sir. Yes.
There are certain challenges that the concrete technologists or concrete producer in precast faces. One is there is demand on very high early strength, because from commercial perspective, the sooner you remove the element from the mold, the better it is. Second is, in many situations, the dispatch of the product cannot wait sometimes for 28 days. And what happens if most of the acceptance criteria of concrete is based on 28 days strength. So there has to be an agreement that either acceptance criteria can be changed to comply with the dispatch timelines, or you have to have very excellent relationship developed between 7 days and 28 days strength of concrete, so that you don't get surprises after the element is in the hands of the customer and you find some problems in the strength. Third requirement is, again, from a commercial perspective, again, for achieving very high early strength, you have steam curing or high temperature curing, which presents another additional aspect to control during the entire process. And finally, because of multiple handlings and basically precast have to be thin elements, they are far more prone to edge damage than the cast in situ concrete, and therefore the impact characteristics of the concrete needs to be also looked at, so that these damages are kept to minimum, and repairs and rejection of the elements can be controlled or minimized. Yes, no, you can. I'm done.
One other point which you just mentioned is the statistical point, that is statistical in QC. How important is the statistical QC in precast work, and how it can be implemented? Can you throw some light on this, please?
Yeah, okay. Let me give me a second to change to a different slide. I hope I have a slide on.
Because normally in cast in situ thing, we are not much worried about this statistical thing, because every time you are not able to get that. So, and especially statistical things are more used in the manufacturing plants. So we have to have a sort of a manufacturing mindset while using this.
Absolutely right.
Yeah.
Absolutely right. So you rightly said precast is more closer to manufacturing or factories rather than the conventional cast in situ or site-based construction. In the conventional construction, as I said, because the client is perpetually present, they can afford to do almost 100% checks, and therefore the concept of statistical QC has not seeped into the civil engineering practices. In precast or in mass production, when you are producing thousands, literally thousands and lakhs of items, it is not feasible, neither economically possible to test every unit, and it's not required, because the consistency of quality in a factory is far superior to that ever you can achieve in cast in situ construction. So this advantage of having requirement of producing the same element again and again for thousands and millions of times, we must leverage and use the concepts of statistical quality control. Here, what we need, and as I said earlier, when I explained the fundamental difference between the two systems, in precast construction or precast thing, it will be the product specification which would govern, because the client at best can do a product check or product testing, and therefore what we need to do is develop crystal clear product specification and acceptance level for each parameter of the product, and that could include number of different parameters. We need to use the concepts of what is known as AQL, acceptance quality level. You need to develop a sampling plan. There could be a single stage or a two-stage sampling plan, and these details or guidelines for this are provided in ISO 2859. I'm associated with one of the precasters, and we are trying to develop a system where we will use this, and acceptance and rejection criteria can be used to minimize the cost of QC in a very effective manner. Also, because we are also buying in bulk number of embedments and inserts, the same concepts can be extended backward to testing, applying the SQC for testing of incoming materials which are coming in units. So you have inserts for a particular product, thousands or maybe hundreds of thousands of inserts. You can't test everything. You also need to apply SQC on that. So the core here is to understand the principles of SQC, and unfortunately, all of us, people like me who have more background in cast in situ construction, this concept is little alien, but we need to learn from people who have worked in the factory background and implement the concepts using the principles enshrined in ISO.
I think for very well said, sir. I think for, as you said, the SQC will be one of the very good tool for control of the quality in the especially in the manufacturing side. So coming to our Mr. Salesh, yes sir, how are you, sir? Salesh sir. Salesh, you have been into manufacturing for so long, and so how do you handle the things, especially the precast elements and this one, the standard operating process of implementing? Because especially when we take into consideration the productions, you go by SOPs and other things. But I would like to understand from you how you are doing the things, especially manufacturers' purview of this QC and QA/QC system.
Okay, yeah. The
Right.
main thing is, as far as the precast is a manufacturing precast factory, the main ingredient that we need to produce is the concrete. So before we start the factory, we have to be very clear on what configuration of molds you are going to have. Basically, if it is a hollow core, then you have tapered molds, you have column molds, you have pre-stress molds, wherein the concrete grade that need to be used are M50, M60. Basically, in the pre-stress elements, M50 grade of concrete, for hollow cores, we need to use zero slump concrete. So before starting of the commissioning of the plant, your concrete trial mixes and stabilization of the concrete is very much important, because this is that you have to achieve the demolding strength that the designer has set for your particular designs. So in order to achieve that, you should have the requisite trial mixes, and once your concrete is stabilized, and it is advisable that you get your concrete stabilized from concrete constructions, like we have Mr. Shashank with James Engineering Services, which are being provided, because once your concrete is stabilized, then all the things will go in a proper sequential manner. The production manager, the production engineers are very well aware. And regarding once the concrete stabilization, then we have the quality manual for your particular factory. Basically, if you are producing table molds, you are producing hollow core slabs, you are producing column molds, then we have a standard operating procedure system mentioned. If it is a hollow core system, then we start with the strand elongation system, then bed master comes into picture, then extruder, then cutting machine, the demolding of the element, demolding strength, stacking, lifting, all those has to be formulated in a proper system of procedure of productions. And there should be a system wherein the production engineer will be a checker, and the quality assistants and the quality control engineers will be the approvers. This system should work in the factory, which will help in achieving the desired quality control.
Okay. Then about the handling of the precast, what care you are taking, and how you are handling the things, and what QC controls you have for handling systems, because you are also doing the erection also of this and transportation. Any standard procedure which you are following in this?
Yeah, basically the element stacking is very much important both at the factory as well as the site. Basically, the stackade that you are having, it should be a well compacted stackade basically, and the stacking system that should be followed, it should be followed as per what is mentioned on the shop drawings. That if it is the hollow core elements, if it is a 200 mm hollow core, the number of elements that are allowed to stack in a stack, it will be 5 numbers or 6 numbers. The designer will be showing that on the shop drawings. Secondly, the lifting system, whether it should be lifted by, it is hollow core, it should be lifted by a spreader beam, or it should be used by a lifting belt. Lifting belt we can use for, suppose 150 mm slabs are there, we can use lifting belt. Above that, we need to use the spreader beam. How much element should be lifted in a single way? 150 mm hollow core should be lifted one element at a time. We see a lot of people lifting 150, 200 mm hollow cores 2, 3 at a time, which is not the correct way. And main important thing is lifting equipments. If we are having long stress beams, then this pressure beam, there we should use proper spreader beams of the requisite capacities. It may be 5 ton, 6 ton spreader beam. The lifting points should be particularly as per the designer what has been shown on the shop drawings. Lifting points, and it should be lifted with the 4 lifting points. There it should be lifted in the 4 lifting points only. It is not the correct way that we are lifting only 2 points have been there. Chalta hai. No, that is if having, then we are having problems in the element. There will be cracking, and we can have an element breaking also. And main important thing, the stacking system that should be followed in the factory should be monitored by a proper stackade supervisor who is well versed with the stacking system. It should not be a normal layman who is supervising the system. Same way, when we are unloading the elements, loading the elements, there is a proper way of using the stack system and the belt and the system that should be chains are there. Vertical element should be transported wide A-frames. Horizontal elements should be properly stacked on the reapers. And when we are unloading at the site should also have a well compacted stacker where it has been done. And unloading of the element should be done in the presence of the site engineer or the project engineer. Because if we are doing with the help of an erection team or a rigger, then later on it will be problems at site that the erection guy will tell that no, the element that has come from the factory, it was cracked first. Then the supervisor will say no, from हमने जो factory से भेजा था तो it was in a very good condition. How we are saying now. So these issues should not come. So in that case, it is very important that the unloading and loading should be done in presence of the project engineers. That way we follow and ensure that the stacking and the loading and unloading of the element is done in a proper way. Erection also, tell me.
From your points, which I find that design plays a very important role, especially while even it starts with your manufacturing of the concrete, because designer concrete has to be used, design of molds, design of even the lifting systems. So I would request Mr. Rajendra Kulkarni to just explain the designer's perspective in this. Rajendra happens to be a great experience in the designs. So Rajendra, can you explain what are the important aspects from design perspective which you are putting in the drawings and other things? So if you can explain, sir.
Sure, Suresh. Actually, as Shashank has explained, that precast is different from cast in situ, that in cast in situ structure is at place. And in precast, the elements moves from place to place. That is from casting yard to storage to transportation at site, and then erection. So apart from normal service loads, that is dead load, live load, or specific loads, these precast elements are subjected to various loads and stresses due to this handling, demolding, and all this thing. So very important aspect in precast construction is we have to take into account this load so that the element performs well till it goes to its place and starts servicing the service loads. Okay. Can I share my presentation? Can I get the presentation right?
Yeah.
So can you see the screen?
Yes, please, we can see.
Yes. So from designer's point of view, the design of element starts first thing from understanding the precast plant specifications. If you see the precast plants, there are different types of molds available for each element. Even if it's staircase, now I'm showing on screen, staircase can be casted as on edge, or it can be casted inverted like this also. The two types of molds are available. Or if you see tables also, we have fixed tables or tilting tables for walls panels. Both types are present in the plant. If you see the culvert mold also, it can be casted in vertical position or horizontal position. So depending upon the plant specifications, these elements are subjected to various additional stresses. Now, if you see this precast staircases, if the mold is inverted mold, then the additional forces coming while demolding will be totally in opposite direction compared to the while staircase is serving at place, means the basis of tension and additional reinforcement will be required. So from designer's point of view, all this need to be taken into account while designing the element, and that plant specifications are taken care. And we have to prepare the drawings, how it is demolded, then how it is rotated, how it is placed in position at plant, and how it is stored like this. So first thing is design for the plant process, means while demolding and placing it in position. Second perspective is the transportation. So transportation also, the designer's intent is to transport the element the way it is placed inside. But we have the restrictions of size, then vehicle sizes, classes. So we may have to put the element in a different way than it is put it site. So that also we have to take care while designing the elements. Just so suppose the wall panels are there, it is intended that wall panels are transported as verticals. If the slab panels are there, it is intended that slab panels are transported as horizontals. Then the supporting positions should be such that they are considered in design. So apart from this plant specifications, while transporting element, generally we give drawings how to transport it, how to support it on the vehicle, so that no additional forces are coming, or the forces which are coming are taken care in the design. Then some elements are like just I'm showing here, which are having very thin elements with cantilever and all this. So while designing itself, we have to take care that while transporting it doesn't get damaged. So we have to put the braces like this while transporting it. And next aspect, while sorry, next aspect is while erecting the element, also the different stresses are coming on the elements. So that has to be taken care, and that has to be mentioned how the element is to be erected. So as Shailesh has told that we have to design various spreader beams or tackles to handle the element at while erecting it. And this generally designers prepare these drawings for the spreader beams and elements and supply to sites. So this is the one of the spreader beam drawing here. So the designer intent, so that designer intent is followed at site while the erecting the element. And last aspect, while erection also, designer has to give the specifications that erection stability. Suppose the beam is erected, because beam is erected, and after that we are putting hollow cores on that. So while putting the hollow cores, it is subjected to different stresses and forces. So we have to take care upon that. So erection dowels has to be put there, and that is to be designed for various forces. That so apart from that, the proppings, if required propping for the beams or slabs, because it is half cast slab, the propping requirement is there. That also be taken care while erection. So all these details, apart from the standard capacity drawing, are very much needed in precast design. That is how to store it.
So this means there is a completely lot difference between what you design for cast in situ concrete and precast concrete. So
Correct.
for a precast concrete, the detailing and the methodology, everything is being mentioned on the drawings.
Yes,
So,
right.
so it makes the designer's works many more time complex than what you do the design for the cast in situ structures.
Correct.
So,
Yes, all these things should be common shop drawings. How where are the lifters position, then how they should be lifted, how the element should be handled, how the element should be stored, how the element should be erected, then how the element should be supported at site while erection is going on. In the cast in situ concrete, about it is done, grid and joint filling. So all this aspects should be very clearly to be mentioned in the design drawings, which are different from the cast in situ.
okay, that's perfect. That's perfect. Now these things are the way you have mentioned here, that the drawings have to you have to keep each and every aspect of it mentioned on the drawing. So it
Correct.
gives a very important that the person who is able to read the drawing correctly,
Yes.
and that is very important. That is a skill level of the person is very much required, and the training to read such type of things and adhere to these type of specifications which are mentioned in this. So what I feel that in this I would come because there is so much of complexity in this. So in India, which we are in, because I've been into precasting for so long, so we don't have much of standards which are available here. So I will come to Dinesh sir, who have been having great experience worldwide, and so I would request him. what is his perspective of this one? Like he had been having an international experience in precasting and certification of the work. And certification is very important in this, because everyone here, what I am finding in India is everyone is working in their own silos. So how we can combine together the specifications and how the factory is set up, the plant configuration, how you are managing the plant configuration in Western country, because most of the experience which we are drawing is from Western country only. So the structured rectification, how it is done. So I would like you to throw some light on the factory setup and the structurals and the PCI,
Sure.
because and the PCI which is there. Please.
Yes, yes. So I agree with you that the design aspect is very, very important, and there's so much people need to put on the drawings, and like you said, you need skill level to read those drawings. It's not easy when you're looking at so much information on one drawing, and so there has to be a consistency in the drawing. So if we standardize products, so PCI is a US body which is into this kind of standardization. So there's nothing where it should not be watered down to a level where a layman can do your designer's job. But with so much of repetition, there's so much people continuously do the same things. PCI has guidelines for everything. PCI has manuals for everything, which makes a new designer's job a little bit easier. So if somebody comes in out of college and they are given the PCI handbook, if you just read through the handbook, you will understand how things are done. The same way, I think even I think ICI has started a handbook a couple of years back. Mr. Pradeep was there and he had done that, and I think that was a good start. I think we need to every year or every couple of years we need to come up with a new book where we can keep adding on to that, and that will help the whole industry. That will help the people who are already in business with precast. That will help the people who want to get into the precast business, and that will help the people who are a part of the conglomerate here. So we just start. I thought, okay, let me start with the PCI. So this is PCI's website, the main page, and there you can just go. There's you click on the design tab. They'll show you resources: architectural, building and engineering, transportation, sustainability. There's guides and manuals, R&D. There's examples of projects, institutional parking structures, and every manufacturer supports PCI and they provide data from their projects. It's not closely held a secret. It's open. People know what are the costs of precast. People know how is things manufactured. We in India, I think, there's still lacking is the openness to share the knowledge which you've already gained through years of experience. I think that we need to start doing that share.
Dinesh, rightly, you have put the hammer on the head, about this. The certification and other things are one of the very important part which is lacking here, especially when people are working in silos. And then the main affecting people is the client, who is not able to decide whether he has to go into precast or not. He has to adopt the thing. If a client is already thinking of adopting precast, but he is not able to do because he is not having resource of a certified precasting. So if a person wants to really have a very good quality, then he should have his own system of quality. And if everybody says that his precasting is good and I am doing this following, so I think it's need of our that all are coming in one platform and take the standardization of the manuals and other things and start in India, so that the customer is assured that yes, this this system, and a plant who is following these systems are the one from whom they have to source the material. What's your take on
Correct.
that?
Yes, correct. So right now in India, all the authorities, the central CPWD and stuff are asking for is a ISO 9001, ISO 14001. I feel that that is not a right thing for us. Yes, it is used for manufacturing, it is used for process control and all that. But as an industry, as a concrete industry, we need to have our own standardized level playing field for all manufacturers. It should not be that if a small manufacturer who's ISO certified and a large scale manufacturer who's also ISO certified are fighting for the same kind of projects, So that is not the level playing field. So I'll go back to PCI. You can see this is about PCI. They have councils and committees. If you take that, and so there's multiple councils and committees if they have. So there's a business performance council, educational activities council, marketing council, membership council, quality activities council, R&D, technical activities. So this is one of the strongest member councils, committees in PCI, technical activities council, and they have a BIM committee, they have blast resistance and structural integrity, building code committee. They work with the IBC and the ACI and try to implement precast standards into the ACI codes and the IBC standards, and the design standards committee. So there's so many committees, subcommittees inside of these big councils, right? So that's there. One is that. The second thing is, let me go back to about. So they have regions and chapters. So they've, based on your geographical locations, they've split, because people from Texas don't want to travel to New York every time there's a meeting. So they have separated PCI West, Mountain States, Midwest. So they've given regions with PCI where these regions can share based on their regional whatever requirements of the clients, of the architects, whatever. So they share that. Now, if you go to the PCI website, there is, the certification. So there's certified plans. If I just go and say whatever, let me see, just say find. If I do all, you could see there's around 275, 276 certified plans. So right there, so 267 is the total number of certified plans in US. And
Yes.
there's a map which will show you all these dots wherever the plant is. So if an owner or an architect wants to do a project, they, in Dallas, you can zoom into Dallas and see who are the certified plants. This helps them a lot. So they call for tenders from these people. The architect drawings are ready. They send those drawings to them, and they can get 2 or 3 or 4 quotes. And so most people work within a region of around 150 to 250 miles. So that is the transportation limitation with respect to precast, and that helps the owners as well. And so this is the PCI website. So this is with respect to the plants. So PCI also certifies plants. They certify the erectors. Most of the times, it's a separate process where the erection is done by some other person, and the plants are only manufacturing. In India, because of the the new concepts with precast, the precast manufacturer does everything, which is okay to some point, but during the long run, it is a capital intensive market. So you need to own your own cranes, you need to have your own crew, you need to have your transportation systems. Everything is in one place. That becomes a large business to handle. With PCI, only the plants only manufacture. They either do FOB or they do delivered at site. Depends on what they go with in terms of the process when this happens. And then there's personnel. So PCI also certifies personnel. So I've opened this page here where they show you. So these are the levels of certification they do. One is a level 1 quality control technician inspector certification, level 2, level 3.
Is it mandatory to have this type of certification for even the technicians also to have the certification of the plant?
Yes. So
So,
they, every
so
time PCI certifies a plant, they will need one or two or some number of people in every levels. So if you are in the just the production, all these three, level 1, level 2, level 3, you need to have people in all these three levels of certified people. Then only you get the PCI certification for the plant. If you're
I think,
a certified director, it's the same thing. You have a certified field auditor, certified company auditor. You need to have a person in with that knowledge or with that certification if you want to be a PCI certified director.
so this also gives a benchmarking figure of any of the person of the skill set available with the company or the people who are available for doing that type of so. So I think this is one of the
Yes,
very key factor which is required for India, and in which
yes,
a platform is made. And I think with the geographical thing which you are telling, ICI is having a geographic presence all over India, and with so much of student chapter and other things. So this can act
yeah,
as a certifying body and other things which we can discuss when we are there in the same con. So
yes,
anyhow, we'll be
100%. I think
discussing that.
ICI needs to take the lead here. We need to have a subcommittee done for precast, and then we need to enroll the precast manufacturers. It needs to be opened up saying, okay, we are enrolling precast manufacturers based on some statistics. So either M cube per day, M cube per year, volume of projects done, something we need to have fields, and that can be published. So if an architect is looking for ICI member certified plans or something like that, they can go on the website. Okay, these people are certified and they've done up to 100 crores, they've done up to 200 crores, whatever. So when that is there, so the contact information is there, so the architects will directly call them. Right now what's happening is they don't know who to go to, so they just ask for references, and somebody says, okay, go here, go there, and it's not a good process which is being followed right now.
Okay. So that this is very important aspect which you are told. And
Yeah.
now coming back to the point of like establishment of acceptance criteria and tolerances which people follow there. I would
Yes.
like to hear from you any formats which they are adopting, which we the current, so that the audience here can understand the intricacies which are going into manufacturing, especially when we are talking about the international practices, which are, if you can share some of the things for the audience, please.
Sure, sure. So PCI website is open to some of the documents which are free for all, which is available on the PCI website. Some are members only, so it depends. If you want members only, then you'll have to become a member, and it's like that. But most of the documents with respect to quality control, tolerances, this that, it's all, I think it's all free to download, so you guys can look at it. So this is manual 135, which is a tolerance manual for precast construction. And what PCI has done is PCI separated two things. One is the structural precast, one is an architectural precast. So they have a manual for quality control for structural precast, and they have a manual for quality control for architectural precast, because architectural precast is a little bit more a quality oriented thing, and the levels are higher for that. So if you go to any of these manuals, just scroll down, they'll tell you how the process is done, relationship of project tolerance to functional requirements, and you just there are good diagrams which are there. I'll just go there directly. So if you have hollow core wall panels, they'll tell you these things, and they give you the uh, A is the length, so plus or minus half inch or plus or minus 13 mm. So you go here, so the length is given, A is the length. So in your length, whatever your length be, the tolerance which is acceptable criteria is plus or minus 13 mm. So if you have a 10 meter, 10,000 mm slab, you can either go 9999987 or 10013. Anything above that, you need to do, there has to be an intervention. You need to do something with it. Either you cut those slabs to match the dimensions or stuff like that. So this is a good base to start with. So when somebody's starting, or when somebody's managing a project, if the precaster does not have any kind of QC dossier or QC document which they are submitting to you, you can say, okay, let's open PCI manual, let's see what they've given. And so there's every individual product has, so this is architectural brick facade, architectural element. Every product has been listed there with diagrams, with the proper dimensions, and you can look at everything and control it. So this is a good starting point for even the Indian ICI can adopt this. PCI does not stop anybody from adopting it. And so, ICI can take this as a starting point and we can make it our own. So we don't do some of the products which are done there. We can do based on Indian conditions, whatever the products we do, we can look at this. So the same kind of things, the QC manual will tell you about. That is this is the tolerance manual, and this is the quality control manual, where they give everything, the design responsibilities, this special finishes, production practices, all that is available, where if people go through this and just read through it, I think that gives you a very good perspective of how it's done. And we don't need to reinvent the wheel. It's already been done in not just PCI. If you look at FIB, which is a federation of concrete in Europe, you look at New Zealand standards, you look at
even
Singapore.
NPCA is also there.
NPCA is there. CPCI, which is Canadian Precast Concrete Institute, which is good. Singapore has very good standards for concrete, precast concrete as well. And so you just go through all these documents. There's so much to read and learn from which has already been done. So the new thing which PCI has started recently is the architectural certification. So previously they only had there's one type of certification for architecture. Now with so much of architects demanding iconic structures in the US, they said, okay, we need to kind of tighten the bandwidth here to see who is good for certain things. In the category A, C, A, D,
Hello.
A, D.
Okay.
So it's
I think there is some connectivity issue.
Able to do it.
I think there is some connectivity issue, Dinesh.
Can my AA so project this is all this
okay.
all
Okay,
is
Dinesh,
a big
just
like request. They said that all their on at least
coming, Dinesh, let me intervene in this. One more thing, one more important factor which I find also, yes, certification is one of the very important thing which is required. Like the accessories which we use in precast. Hello.
is seat line.
I would request Mr. Shailesh to come to the point of this, how you are managing the, there are so much of material available, especially for this accessories. So some accessories costing 1,000 rupees, some same accessories costing 500 rupees. So how do we decide that yes, this is the accessory which is okay for us? As a manufacturer, how do you come to that decision? Because see, some which you are importing and some are making here in India. and this makes the decision of the manufacturer very difficult, what to adopt and whether the quality of the. So how do you manage this type of issues in your manufacturing?
Basically, the embedded accessories that are required are basically the dowel tubes that are required for column or wall molds. Then we have the lifting anchors. There are Fremeda, there Deha. Presently, if we go by the European suppliers, that is Halfan, FIFA. So the cost of their embedded accessories as compared to the Indian suppliers, there is almost a difference of 10 to 15 times in cost. So while designing, we ask the designer to design the elements, preferably considering the Indian embedded accessories. There are certain local available suppliers there which are having OEM in China, or some are manufacturing in India itself. So we provide the test certificates of those suppliers to the designer. He will evaluate it. If it's okay, then we can go with this suppliers. If that is not okay, then there are certain methods which are not still established for certification of this embedded accessories as such.
Is there any body who is certifying the accessories here in India?
No. There is nobody.
So I think this is one of the areas which require a level field play for all the accessory manufacturers and things, so that the manufacturers have a clear understanding and they can source the material. So sourcing of material again becomes a difficult part for the manufacturer.
Even the couplers which are now being regularly used, there is type 1 coupler, type 2 coupler. There are n number of agencies which are providing the couplers, but there is no such certifications, or it is only the approval that has been provided by the structural designer. We are using this, but there is no certifying agency as such.
So this also becomes a very important part of establishing, for the manufacturer to get into this manufacturing, precast manufacturing.
Yeah. They are the main important
all these things. So what I feel that in this, so much of data is there, especially for the everything we have to collect data in this. So how digitalization can help us in this? So Shashank sir, can you throw light on, because so much of QC has to be done, so much of measurements at site also you have to see, say, suppose grouting is there, double tube grouting is there. So how do we know that yes, so much of grouting has been done or not? As a third party, what is, like, you have been doing quality assurance in the projects, how do you manage the so much of data and because you have to certify the and your responsibility becomes much higher because you are the certifying agencies in some of the cases. Right. So right. how do you take into this perspective, your perspective of how to control the things as a third party, or use of digitization in QA/QC systems? Would like to understand from you, sir.
Sure. Thank you. I think it's a very relevant subject. Is my screen visible?
Yes, sir.
Yes, sir.
So as you rightly pointed out, we are doing a lot of third-party QC, and we have ourselves been developing digital apps for quality control, or you can say quality management. But we haven't done this for precast industry as yet. We have done this for cast in situ construction. But I believe the principles, the advantages that apply to the digital technology in cast in situ would equally, if not apply even with greater returns in precast technology. One of the biggest advantage that we have noticed is by embedding the workflow that is expected to take place in the field in the digital app, we can ensure that there is no deviation from the workflow. So anything anybody wants to do without an approval which is part of an approved process, an alert can easily be created, and real time, in time, immediate alerts can be created. The also very huge advantage, and you rightly pointed out about the data. I'm sorry, I'm not. I think I have something else. Yeah. So as far as data is concerned, in the conventional system, the data is all manually entered into checklists, and there is a lot of difficulty. The data is generated at a construction site, and you cannot carry a device. You can't, it's difficult to go and do the work at the same time capture the data. So generally, engineers note down something in their diary, and then they come back and enter in the checklist or in an Excel sheet. Using a digital app, this process of collecting data becomes absolutely easy, because you need only a smartphone, which everybody carries to the site. Second is the integrity of the data is assured, because somebody has entered the data, it is traceable to the person, it is traceable with a date and time stamp. Somebody cannot then overwrite or replace or change the data once it is entered. So the data integrity is extremely important, and data will not be lost, because data, apart from being saved in the memory of the cell phone, it is also instantaneously uploaded in a server, and it's there for life. And because of that, retrieval of the data becomes extremely easy and quick. The data is available to all the stakeholders. The same data available to every stakeholder live 24/7. Whoever has been given the authority to use the app, either as a user or at least as a recipient of information, everybody is having access to the same set of information. And the biggest advantage is it promotes data analytics. You can have a dashboard, you can do a Pareto analysis, you can do control charting, you can do statistical calculations. These things can be embedded in the digital app. And the engineers, even if they do not know the formulas, they don't have to know the formula. They will demand this particular information, and it is available at their fingertips. So compliance to workflow is one big advantage. Dispute between the doer and checker it virtually vanishes, because nobody can fudge any information. And integrity of the data and availability of the data is another huge advantage. It virtually becomes paperless. So the apps where we are using, we can create everything without use of one single piece of paper. But I have found that the mindset in the field is still not, where people are not comfortable. Some people still want a signed piece of document. It's possible to convert what is digitally available in the server. If the formats are known, we can convert that into a printed output, printed report. But as become more and more familiar to the people, I think the demand and need to use some kind of a printed information and get signature of the quality engineer or the execution engineer will slowly dissipate, and then we might perhaps move towards a typical real paperless environment. It fosters faster decision making, more analysis based decision making, rather than decision based on a particular person's perspective or judgment or opinion. And it also ensures that no check is missed. So in Precast, it is actually possible, if you generate a proper workflow and develop a label, develop a digital app, you can actually print QR code on the element, which will contain all the information about when was it cast, what is the drawing on the basis of it was cast, who inspected. Everything is actually possible. You can auto generate an ID and label, and it connects to the traceability requirement that I had earlier shared as a part of my explanation about the peculiarities of precast construction. So I see huge benefits and huge requirement of digital apps in the precast. One advantage in precast compared to the cast in situ is much of digitalization can happen on the desktop. Not everything needs to be put on a cell phone or a smartphone, because we are working in a factory environment. You can reduce the dependence on networks and smartphone, but that still would be necessary. You can create a hybrid system where you can fall back on a desktop if there is an issue in network, but I don't see in a factory that would be a problem.
I think it can be well integrated even with the BIM modeling and models also, and so that we exactly know where are the differences which are being done, and even understand the thing if any corrective action is to be taken. What I feel.
Suresh sir.
Yes, sir.
Yeah.
Yes.
As Sachan sir was rightly saying, the system has been implemented in Precast India Infrastructures Pune as associated with them as the Chief Technical Officer. We have been working with the track, and that system has been implemented. It works very well, and there is a total quality control on that. It is a very good system.
So practically you have experienced it, so you are happy about it. So I think it's a great confidence. Okay.
Yes.
That's fantastic. Rajendra sir, can you throw some light on this one, like digitalization, especially with the use of the BIM models and how we can control the quality and the assurance? Basically, it is more on the assurance part, because the process and other things can be well controlled in that, put up to the management and also the elements. So how do you see that?
Yes, as rightly said by you, the building information modeling is the new way now to achieve all this in design also. Means nowadays the complete detailing of the precast element is done in 3D environment, whether it is BIM platform, whether it is Revit or Tekla. So it almost structure is virtually built on computer first. All the classes are removed, and then it is sent to the plant and then to site. So this, I'll tell you, we are almost now, as far as we are concerned, we are almost on now 3D platform, BIM platform, Revit and Tekla. We have stopped doing it in 2D now. So this helps. Digitization has helped a lot in detailing also. And this beam, that is building information modeling, helps us not only in detailing, but it is taken to the site also for construction progress monitoring, then even for commercial monitoring also, and to the next quality monitoring also, to the next level also.
Yes. Good to note this. And then coming to this one, Salesh.
Yeah.
How you are managing this, especially the skill manpower? How you are managing the skill manpower, especially in the concrete sector and even in the tower cranes, and because these are the skills which are very much required, especially in the operation side, and the upskilling of the people too, because whenever we always have a shortage of the skilled, especially the loaders and the crane operators and this one. So how do you manage the upgradation of the people? Because now what was happening is we taught some of the people, we brought from rather I would say we imported some of the people from Dubai and other places, and we taught the people, and then as soon as a new plant comes, people are pushed from one plant to other, and then nobody wants to train the people, but they want to take the trained people from this one. So how do you look into this one and give a training to the people? And is there any institute where precast training is being taken up, or any institute where the precast as a subject is being taught, or what is your experience in that, sir?
Yeah, presently, as rightly said to you, there was presently some imported persons who were managing the precast industry. But as the precast industry grow, now we are definitely having the skill set very low. In this case, the option that is with you is you have to train the people. Basically, if it is a hollow core machinery or a pre-stressed thing, there it is not a big problem, because the machinery is driven by the operators who can be trained by the respective European suppliers. If it is Northern PNT, Ilmatic, they train the people. There's a cutting machine, everything has been trained. Even we have a good stressing machine operators which can be trained. So pre-stressed hollow core slab beams is not a big deal. Where we have this precast wall elements, beams, which are basically used for the residential sector, or the precast columns that we are using for the commercial complex. There we need the skill set. In that, basically, you should be developing your own in-house team rather than going for a contracting or somebody depending on somebody, which can be done. As far as the mold fabrication goes, we should have a fabricator in place, which are available in the market, a PAB shade who is working in PAB. He can be also a useful guy in precast industry. We can train the fabricators, the welders to make the molds, or mold should be welded at sometimes. They can come into picture. Important is the fitting of the embeds and the accessories. We have to have some workshops, training sessions. We should identify the in-house labor who are a little bit smart, who have good grasping and understanding power. We should recruit them. We start implementing, getting the work from them, and in this way you go ahead. As far as concreting is concerned, it can be done from normal labor, but as far as the finishing part, when it comes, you should go either for a floater, or you should have the masons which are having a good skill set. They charge normally, a skilled mason charge somewhere around nowadays 1,000-1,500 rupees. So that kind of labor should be used. It should not be a normal mason. Then all the things go for a toss. And second thing, as far as the vibration systems that are concerned for compaction, if it is a table mold, tilting table or fixed table, we should have the proper vibration system attached to it. It may be a common system wherein there will be vibrators which can be changed from table to table, but it has a common synchronizing system. Because vibration with the help of a poker vibrator doesn't give that compaction to the element as compared to what the vibration system gives. Nowadays, what is happening, major of the suppliers, they are coming with some ideas which are suited to the Indian manufacturer because who want to put a factory. They will tell you, a tilting table kya hai, usme kya rehta hai, you have to do it. We can make it, we can get it done from a local fabricator. Vibrator system ki zarurat nahi hai, we can have just the poker vibrators. Profile system ke liye kuch jitna khas zaruri nahi hai, we can have the plywood with some brackets behind it. They are not using magnets, they are not using the MS material or the profile shutters and systems that make the formwork of the particular element. They should be also of the good level. That should be MS, which is having MS. We should have
that is standardization of the formwork.
Yes.
Shuttering material, because shuttering material is one of the key factors in the concrete.
Yes.
The type of concrete making, the type of mold. So mold design plays a very important role, and the skill set of the manpower who's there should be, especially in the mold manufacturing. Also, you should have right manpower who are good in especially laser cutting and other thing, and assembly of the making of molds. So we must have a proper backup for the precast industry, like mold manufacturers. There has to be a proper certification of even mold manufacturers also who are, and the specification of the mold, especially the Rajendra will be able to tell in this, like designer's perspective of manufacturing of the mold.
Yeah, I want to add something. Yeah. As far as this, as you rightly said, the system should be certified, the formwork system should be certified. In this, now there are some system wherein now if there is we are getting a rubber chamfer from a company called Bianchi, wherein it is placed at the bottom of the mold of a profile, wherein it does not allow leakages of slurry from the bottom. Basically, presently what everybody does is they are putting the silicons wherever the gaps are there. Yeah, styrofoam. That is a little bit problem. Though the principal cost is more, but the operational cost and the later on the rectifications that you have to done on the precast elements, that will save a lot of money later on. And overall quality of the product is quite good. And it gives a little bit confidence to the working men also. Okay, I'm using some standard equipment, tools and tackles and place, and he will approach of doing the work will be in a proper manner as compared if you are not using the right tools and tackles.
Fantastic. Rightly said, the cost of quality is normally paid by the owner, or it is in the repairs which the manufacturer himself pays, but he doesn't know.
Yes,
He pays on cost of rejections, because number of rejections. So you can find out that when the data is available, as Shashank sir said, the artificial intelligence coming into picture will come, and a statistical model which you were telling, sir, that will come, which will be, by that it will be evident that how much manufacturing rejections are there, how much with that type of if you are able to manage the data and you are able to analyze the data, you will come to know the actual cost of production. Because in precast also, where when people adopt precast, they always say that precast is costly. But when you take the whole cost into picture, then precast becomes easy, the cost effective. That life cycle cost of the precast, then it is there. So I'll come back to Rajendra sir, especially for the design aspect of the molds. If you can throw some light on the, because that is one of the areas where in India we are lacking the reliable mold suppliers and the designs of mold. Do we require special designers for the molds, or in your shop drawings only you cater for these mold designs?
Actually, for precast, if you see the basic crux of precast is the repetition, means casting number of elements with the same mold. Means if you go for steel mold, if you see some European molds, you get 500,000 or more than that also repetition. So for designing the mold here in India, we'll have to take that aspect into account while designing it, that we should get number of repetitions that it cost justifies. And while getting the repetition, the quality aspect is, first thing is it should not be get deformed, and it should serve the same, it should give the same element, first element also and last element also. Okay. So while designing the mold, there are two aspects. There are it is designed first is, if it is non-prestressed mold, the basic thing is the demolding forces coming on the mold. Means you see it is a lot of adhesion is there between the mold face, and even though you put lubricants and all this, lot of adhesion between concrete and mold. Recently we did one project for Mercedes-Benz where the double T's were there. The double T was weighing some 24 tons, but we put load cell and calculated the demolding forces. It was about 35-36 tons. So that much demolding forces are coming. So our mold should stand for that, means okay. And second thing, the pre-stressing is there, pre-stress elements are there, then this mold should be designed for pre-stress force also. So taking into account these forces and also the repetitions of so that what should be just made. So all these aspects should be taken into account while designing the mold.
Certainly, because we pay a lot of cost on the, we pay for the failures of molds a lot, because in precast plant, when there is a fail, when you are not able to produce, the whole cost of the idling of the manpower goes into the picture. So we have to be very careful, especially in the manufacturing, that our plant runs at the maximum capacity.
Correct.
So that's fine. So we can take up some question answer if something is there on the box.
Yes, there are some questions, some interesting questions are there from audience. So I will just start asking those questions first. Like there is one question like pre-stressing elements, the pre-stressing placements to sometimes affect the integrity and strength of the precast segment. How to avoid, means it is being asked like a congestion which happens while placing the pre-stressing strands in an element. So can Rajendra answer this, like how to avoid the congestion of pre-stressing strands or reinforcement in a precast element?
Okay. Actually, from designer's perspective, I'll tell about this. See, in India, the structures currently are very volume for precast. Means so structures are designed in mind with cast in situ and then transferred into precast. That is happening. So this congestion problem is happening. Okay. So first thing is, our pain point is always the joints where the congestion happens due to pre-stressing. Also, the pre-stressing is done to resist the gravity loads. Okay. And the other reinforcement, top reinforcement, and bottom reinforcement are required for the lateral forces. So while designing, but we'll have to first the model the structure so that this lateral resisting elements and the gravity elements are separated. This is little different aspect compared to the designing the cast in situ structure. So structural, while planning the structural system itself, we should plan such that these are taken care. We should not convert just cast in situ structure into precast structure and design it. Then all this problem will face. So from design
Yeah,
point of view, this is
clashes.
very important aspect.
Clash. Normally we face clash problem, clashing of the bars and other things in the precasting. When you change from the cast in situ to precast, then there is emulated design in which you do the designs and then try to fit in the precast. So yes,
So
if it can be taken up completely, it will be
take
good.
the advantage of stressing for resisting gravity loads and separate it from the lateral resisting systems and formulated structural systems so that our life will be easy.
Right.
Yeah.
Thank you.
Tripathi, there is one more question, interesting question that is coming up is like there are already some PCI and ICI guidelines in place. Then why do we need to go for any other guidelines? Can we not just follow those guidelines?
We can follow, but what happens, in India, we follow BIS and other things. BIS standard is there. And in PCI, they are normally following their standard in their country. So it can be followed here, but we have to change certain points we have to change. Like in India also, when the codal provision has been done, in codal provision, what is there that you can follow the other code which is similar to nature. So we can follow, in principle we can follow, but it will be very good that we make our own system in India following that as a this one, because in that, if you just see, it will be the measurements will be in inches and feet and other things. So in India we are following SI system. So that type of issues may come with the young generation who is there and coming and conversions and other things. So
Yes.
so when we are working in Indian conditions, we can do that. Yeah, please.
Yes. And plus, while following this PCI, again, we need to see that PCI generally follows the cylindrical strength, whereas we follow the cubical strength. So that
Yes.
conversion also
Exactly.
needs to be
Same point I wanted. Yes.
Yes.
Also, I think we
And
should understand that the
yeah.
ecosystem that is mature in the American industry, we have not yet matured to that level. If you suddenly impose something like certification, if they said there has to be certified workmen and you don't have a certification system, you cannot suddenly migrate from what exists in India to a PCI standard all of a sudden. You need to calibrate that growth.
Yes,
One more thing I
Sanish.
need. Yeah, one more thing that is that IS codes are very much silent on design of hollow core slabs, the rejection parameters, slippages, cambers. So I just want to know, in that case, we have to follow the PCI manuals, because as far as hollow core slabs are concerned, basically most of the designers I have worked with, they are using some softwares. If it can be Ilmatic software, yeah, it can be a marketed software they are using for hollow cores. But IS code is very silent on that.
Yes, our codes are not addressed issues yet. It is evolving. That's why
I
think
think
slowly
with time things will evolve and this will be available.
Yeah.
At present, not many of the hollow core manufacturers are there, and so I think with the popularity of hollow core, especially in the commercial spaces and other things, people have to understand. Yes, hollow core is one of the miraculous material which is available for the designers. So then the things will certainly, and for in general, those who understand hollow core do take into consideration the PCI guidelines and work. So, and it is acceptable in Indian scenario also.
Yes. Then there is another question which says that this one is very interesting question. Mr. Shailesh, can you answer this? The question is that, is there any acceptance criteria for the numbers, the density and width of the depth of the cracks in precast element? So basically he wants to know whether there is any criteria to accept whether these many number of cracks are available or this much density of cracks is available, acceptable, or the width or depth of the crack. So can you throw some light? I think everybody can share their views on this because this seems to be a quite interesting question.
Yeah, precast tolerances are mentioned in IS 1447-1985. But as far as cracks are concerned, basically it depends on the depth of the crack, what sort of cracking is there. It may be due to, there may be a lot of silt in the concrete. It may be due to the element is not been cured properly. It can be the cracks can happen if the element is demolded before it has achieved the demolding strength. It can be, cracks can be formed during the handling and shifting of the element also. So there is not a, as far as the acceptance criteria is concerned, we have to go back to the structural designer, share the pics with him and ask him, structurally this element is acceptable, or there are the structural rectification methods that are available. We should do all the admixtures and chemicals that are available to get that element rectified. This is the designer's approval, and accordingly we have to go for that.
Actually, in this, very important factor in this is the quality inspector which is there, his judgment of the things. He must be trained to understand what type of crack it is. Basically, the training which he should receive is the troubleshooting and understanding what is the concrete, how is the element behaving. So if he is able to understand, that is the first level of the quality inspector which is there in the plant to judge whether this crack is a shrinkage crack or it is a structural crack. So all these things have to, and when he identifies that it is a structural crack, then other things come into picture. So there has to be a proper system in which the person is trained to know how to understand the cracks. See, understanding crack is also a subject in itself. So it's a very vast subject.
It's very important. Location.
Yes,
sir. Yes, sir. Please continue, sir.
Okay, so another aspect to be added here is a crack acceptance criteria cannot be an omnibus criteria. It has to be a product specific criteria. For example, a box culvert is a double bulb T-beam or an architectural panel, all will have their different requirements. Some are structural, some are aesthetic, some are functional, and you can't apply a single acceptance criteria. You need to choose the element, its functionality and application, and determine. What is cutting across common to all of them is perhaps durability. And in durability is generally recognized that 0.2 mm band below are called hairline and minor cracks unacceptable. Anything above this, you need to look at the exposure condition and see whether they are acceptable.
More thing important, the cracks that have been found in the hollow core slabs. I am stressing below a lot of hollow core because nowadays hollow core slab is very much used in commercial complexes. It has become a grade of 8.4 meter, 11 meter by 11 meter. The hollow core is coming very nicely. They are going for some hybrid structures like cast in situ columns and hollow core and pre-stressed beam, which is coming into picture. There is no as much study on the cracks. Hollow core, what are the rejection criteria of the hollow cores? Somewhere we found that it was a crack below the core. Somewhere we found that the crack is top crack only. At that time, we go to the structural designer. Sometimes the structural designer is also not able to analyze it properly. Then we go for the PCI manuals. In my case, I have gone to the Italian supplier. We have Northern PNT. There is a technical guy, Mr. Sandro. I had a conversation with him for almost 3 to 4 months. He guided me what are the cracks, how to identify, then how to play with your concrete, what are the things need to be cared. And that way we develop, and now little bit we can say, even Mr. Shishang team has helped us engineering for stabilizing of the concrete. We are now using little bit artificial stand also to cater these problems. Though the cost of concrete is little bit higher, but it has now made our life easier because we are getting a good demolding strength at an early time. Suppose previously we were having 24-28 hours of demolding strength for hollow core slab. Now we are having it at somewhere around 16 to 18 hours, which has again helped us in our production cycles. We are having 4 beds now regularly from 4 beds, which is a very good achievement.
I think 16 hours is a very long time.
Yeah,
It should be within 10 to 12 hours maximum.
Yeah, but for that we need to have those boiler system and hot water pipe, curing pipes and everything. And looking at the cost of that and operating the boiler, the manufacturer or the owner is very reluctant on that.
Okay.
Okay.
Good.
Rajendra, would you like to add your view on the cracks issue?
Structural point of view, first I think we'll have to identify the location and orientation of the cracks, whether it is structural crack, whether it is on tension phase, or whether they are non-structural cracks, shrinkage cracks. First thing, and second thing is we should develop the crack repair mechanism also. Means there are some documents available in PCI also for various types of element, hollow core, double disc. Similarly, or we should develop the document here how to repair the cracks, whether it's structural then non-structural, and it should be available at erection site, means construction site, so that it is taken care. Means whether it is structural or non-structural, if it is structural but it repairable, all cracks should be repaired because it affects at the last durability of the structure.
Perfect, sir.
Yeah.
Perfect.
Another interesting question is there on the what type of QA/QC to be followed on precast mold during inspection? So in general, what should be the minimum criteria for inspecting the precast molds? So
I can have my sharing screen.
Yeah, sure. Can someone give him the right to share his screen?
Just a second.
Are you able to do that, or how is that?
Is it visible?
Not yet.
Hello?
No, not yet.
Waiting to write on the screen. It has not been shared.
No, actually, we're not able to see that.
Maybe you can summarize without showing the screen.
Yeah, it is basically we can have the formwork. It should be, we should have the quality plan basically wherein we have the formwork checklist. We should be coming to picture where we should have the which element is being produced, the drawing number, the shop drawing should be attached. What are the location of the embed and accessories mentioned that has been placed properly. The steel or everything is been in place according to it. And basically then the production engineer, that is the checker, will get it approved from the QC engineer, that is the approver, and then we can go further. So it is basically a process which should be defined, and accordingly we have to move it.
Okay. Then we'll take another question. I think we are almost there in our time allotted for this thing. So I'll just take one last interesting question. Then Tripathi, then you can just summarize the whole thing. 1 minute.
Then you can open my screen also, that presentation screen.
Yes.
Yeah, please go ahead with the questions.
Yeah, 1 minute. I'm just. There is some question about in precast how to avoid leakages in hollow core slabs. So we were just discussing about cracks in hollow core slabs. So in that same line, Mr. Shailesh, can you throw some light on this? How to avoid leakages in hollow core slabs?
Leakages in hollow core slab. Basically, hollow core slab is always designed as a composite slab, wherein we have the hollow core with a screed topping, that is a structural screed topping. Between two hollow core slabs, we find there is a V joint, which should be also provided with some anti-skid reinforcement. It can be a C bar, U bar, L bar, or it can be a lattice girder. And when we are doing the screed concrete should be properly compacted, leveled, And if that is the case, we will not find any kind of leakages in hollow core slabs. Basically, when you are, yeah.
Okay.
Can I add something to what Shailesh sir has said? I think we have overemphasis on strengths and cracks, etc. I think Rajendra will agree with me that deflections also need to be controlled. And when you put multiple slabs side by side together, and if they have different deflections for whatever reason, either their stiffnesses are different or their creep characteristics are different, and if the adjacent pieces try to behave differently in stiffness, then the integrity of the joint would go away. And then even though at the time of completion of the project there is no leakage, it could surface sometimes later. So we must make sure that all the panels which are adjacent to each other behave consistently, like, you know, they have similar stiffnesses.
Yeah, while we are doing the geometry of the building, the plate area, we have the hollow core layout. Basically, we have the hollow core plates, we have the part slabs. As you rightly said, we have the chambers predefined in our design, and depending upon when they should be erected, their erection time is 7 days, 15 days. That way they are being erected at site, wherein this problem of difference in chambers will be not be there.
No, chambers can be controlled by the way how you are erecting also. And when you are erecting it, so chambers, see there proper procedure for erection also, where when you do the this one and alignment of the hollow cores. So when you are doing that, you can manage that chamber when you are, and when you are doing the topping on the this one, so chambers can be controlled in that procedure. There is a set procedure for that also during erection. Yes, please.
Yeah. As Shashank said, the differential deflections of the adjacent hollow cores is very important point to monitor to avoid the leakages. One of the reasons for that, Shailesh pointed out that the slippage of the strand, which may cause differential deflections even if it cast in one pore, or sometimes if the project timelines are very tight, so we get hollow cores from two different plants which are totally different characteristics even for same span. Then the differential deflection happens. So this is a very critical point as highlighted by Shashank that the differential deflection, if we avoid it, it will help in avoiding the leakages through joints in the crack.
Right. Perfect. Correct.
Okay. So is my screen visible?
Yes. So okay. Let me sum up the things. Next slide, please. I think we have covered most of the things. Now, taking into consideration that when I sum up, that any precast plant must have a total precast quality management as a complete overview has to be done. And then in that there should be a assurance, and then this is the complete, basically a circle of quality circle which is there. So quality control must have three factors, that is detect, act, and validate. Next slide, please. So next, I think we have covered most of the points. Next. So in this, one of the most important aspects which I would like to summarize in this, that there has to be a proper management commitment to the quality and quality control programs when we are looking into precast as a whole. Then there has to be quality personnel at all stages of design and production. Then clear and complete shop drawing should be available to the manufacturer. And then there is a control of dimensions and procedures. These are some of the points which we have touched upon, and these are very important aspects, especially when we take into consideration the precasting. Then proper positioning of all the embedments, correct size and positioning of reinforcement, proper positioning and adequate mixing of the concrete, proper handling and placing and consolidation of the concrete, appropriate and controlled curing, proper procedure of detensioning and stripping, the proper procedure of handling, storage, transport, erection, precast members, and complete and accurate production documentation. That is the final, when you just put the documentation in this. Next slide, please. Now, coming to concluding, I would say that We cannot just say that yes, this is production में मैं हूँ तो मेरा काम production है, फिर किसी का reinforcement का मेरा reinforcement मेरा transport है. It is a complete, as a company, quality becomes everybody's responsibility. Either you play your part on it, or the whole plant or whole ship is going to sink. So nobody can feel happy by just saying that I'm doing a great job. If designer only says that I'm doing a great job, but the whole other aspects are not being looked in, so the ship is going to sink. So my submission is that QA and QC should be taken very seriously, and it plays a very important part in the precast. So to know further, I would request that most of the audience who are there to come join us in our SEMCON in Pune, which is going to happen on 10th and 11th. And with that, I conclude. Anything else? Yeah.
So thank you, Tripathi ji. I think Ultratech team can now take over for vote of thanks. Thank you.
Thank you so much to all the speakers for such a detailed panel discussion and for answering all the questions. Now there is a quick update on our next webinar session, which is on 4th of December. The webinar is on a very captivating topic, concrete strengths in past 100 years, by our very eminent speaker, Dr. Bishwajit Bhattacharya. Link to registration will be provided on your registered email ID along with participation certificate for today's session. Now I request Engineer Vipin Chaudhary sir to give the closing remarks.
Thank you, Sana. First of all, I would like to thank the ICA Pune Center for this wonderful panel discussion on the topic of QA and QC system in precast construction. And I would like to thank all the panelists, Shri Shailesh Dhereji, Rajendra Kulkarni ji, then Dinesh Bhandari ji and Shashank Yadav ji, and definitely the moderator, Mr. Suresh Tripathi ji and Dhananjay Bhosle ji. Well, all the panelists has covered various aspects of the precast. Either it's the skill manpower, digitalization, quality control parameters are there, various material equipment which are involved in precast. The codal provision, the logistic part is also one of the important thing is there. Then the lastly, which the Suresh sir has mentioned, that quality is everybody's responsibility. I do agree with you, sir, and everybody should take care that their own ownership, and definitely the precast industry is going to way ahead, because in 1950 it was almost zero, but now in India the precast industry are gaining a big market share now. So I would like thanks once again all the panelists for the wonderful discussion. Thank you.
Thank you.
Thank you so much, sir. Now an announcement for all the participants. We will be taking a quick survey in form of polls, as your feedback matters to us. A questionnaire will be flashed on your screens. Kindly fill it and click on the submit option on the top right corner. So now I request the organizers to start the poll and flash the very first question. Can we have the results, please? Can we have the second question now? Can we have the results, please? This is such an enthusiastic and encouraging response from our participants, and now I would like to thank all our participants for sparing few hours of your valuable time. Special thanks to all speakers for such a detailed panel discussion. We hope you all found this event valuable. Thank you for your participation.
Thank you. Bye.
Thank you. Thank you very much.
Thank you. Thank you, everyone.
We can log out?
Yeah.
अभी तो बजट टाइट है दुबे जी, मैं कोई दूसरा सीमेंट आपको सोचकर बताता हूँ।
पापा गड़बड़ हो गई।
डोंट वरी बेटा, हम फिर से बना लेंगे।
राजीव, कोई दूसरा सीमेंट, आगे चलकर कोई गड़बड़ हो गई तो?
डोंट वरी मम्मा, हम फिर से बना लेंगे, है ना पापा?
अरे ऐसे नहीं होता बेटा, घर थोड़े बार बार बनता है। हाँ दुबे जी, वो सीमेंट सिर्फ अल्ट्राटेक ही लगेगा। हाँ बिल्कुल पक्का।
घर बनता है जिंदगी में सिर्फ एक बार। बनाइए इसे देश के नंबर 1 सीमेंट से।